Hey all, welcome back. In today's topic, we are going to discuss about always block. So, in the previous session, we have already discussed about the initial block. If you didn't see that session, I'll be linking that in the description box. You can go and check it out there. And in today's topic, we are going to discuss about always block. Okay, so what is this always block? So, in the previous session, we have discussed that initial block is something which will be executed only once, is it or not? So when coming to always block, it is opposite to that. Like you can execute the always block any number of times you need. Okay, so this is the main difference between initial block and always block. Like always block is executed only once, whereas initial block can be executed any number of times that is required. Okay, and also one more difference is that initial block is non-synthesizable. Okay, in order to know the difference between synthesizable and non-synthesizable blocks also, you can see that particular session that I am linking in the description box. So coming to always block, it is synthesizable block. So that is why mostly you will be using the always block in the RTL design. Okay, rather than in the test bench, you will be using initial block, you will be using it in the test bench, and always block you will mostly use it. That I'm not saying that you don't be using this in test bench, but mostly you will be using the RTL, it in the RTL design. Okay, so this is about always block. And just like for initial block you will be using the initial keyword, for always block you will be using the always keyword. Okay, and this is also followed by begin end, similar to initial statement. For example, if you want to insert some two or three statements within the initial block, what you will do, you will be writing it within begin and end, is it or not? In this always block also, if you want to insert some three or more statements, then you will be writing it within begin and end. Got my point? So this is about always block. So it can be executed any number of times, and it is synthesizable, and also it is used with keyword always. And in order to have one or more statements, you will be writing it within begin and end statement. Okay, and now coming to the main point. So I already told you that always block can be executed many number of times, is it or not? So for this many number of times, how will the execution of this always block will be being done? Why? Because basically, for example, in the previous session we have discussed about initial. In initial, what you will be doing, you will just be writing the initial keyword. Within begin, you will be writing some statements, and end. And these statements which are written within the initial, they will be executed only once, finish. Okay, in this way, by writing it within initial, only by writing within begin and end, they will be executed. But in always, these statements has to be executed like any, for example, if you want these statements to be executed for 4 to 5 times, they should execute for 4 to 5 times. Now for this execution, are there any rules here? Yes, of course. So while writing always, the syntax in order to write always is nothing but always keyword, okay, followed by at the rate symbol, and within the parenthesis you will be mentioning something. Okay, so and then here within this begin some statements, and then end. So this is how you will be writing the always block. So this is the initial block writing, and this is how you will be writing the always block. If you see, always at the rate, and within the parenthesis you will be mentioning some variables. For example, a, b, c, these are the variables you have written within this parenthesis of the always block. So now what will happen, anything that you have written within this parenthesis, like any variable you have written within this parenthesis, they will be the reason for this execution of the always block. For that means, for example, this a, b, c that you have mentioned here. Okay, so any change in this a, b or c value will trigger this always block, and then the statements within the always block will be executed. Got my point? Yes, this is how the always block will be executed. So this, I mean, the within the parenthesis what you are mentioning, okay, these variables, this is called as sensitivity list. Clear? This is very important in always. Okay. So while anyone is asking you about always block, this is very important, like how you're going to write a always block and what is the sensitivity list in the always block. These are the two main important questions that arises when discussing about always. So always at the rate, okay, and then the sensitivity list, right, and then begin some statements end. So any change in the variables within this sensitivity list will trigger the always block. Triggering is nothing but it will activate the always block and the statements within the always block will be executed. Got my point? So this is about the always block. So the identifiers that you are mentioning within the parenthesis, that means these are called as identifiers. So these identifiers can be either single identifier or a group of identifiers. That is what I told here. Either it can be single or a list of identifiers. So that is called as sensitivity list. Now if there is no sensitivity list there, then what happens? Okay, so if there is no sensitivity list means then the execution will be done continuously. Always block executes repeatedly. Why? Because it is always and there is no limitation for that. Since there is no limitation for that and you didn't give any limitations, like here if you see, if I mention like a b c, and if you are taking like some variables like a b c d e f, these are the variables you are taken, and within your always block you have taken only three variables like a b c. Now what happens? Any change in these three values will only trigger your always block, and the remaining three variables, any change in these d e f doesn't affect this always block. Why? Because you have also already mentioned the limitation for your always block. What is the limitation? Only if there is any change in A, B or C only, then only your always block should activate. If not, it shouldn't activate. But for example, if you didn't give any limitation for this, then what happens? For any change in all these values also, it will trigger. Okay, and multiple always blocks are also valid, just like in previous session we have told that in initial block also we have discussed this point, like you can have any number of initial blocks within your code. Similarly, you can have any number of always blocks within your code. It is not mandatory that you should have only one always block in the code. Okay, you can have any number of always block, but again you shouldn't have a nested always block. That means you shouldn't write always within always. Nested always is prohibited in Verilog. Just like nested initial is prohibited, nested always is also prohibited in Verilog. Okay, so this is about the always block, right? So now let us talk about sensitivities. That is what. So when in coming to always, the two important points are like always, how you are going to write the always, and the sensitivity list. Sensitivity list is very important in when coming to always, because depending upon the sensitivity list only your always block will be working. So that is why sensitivity list is very important. Just like say, okay, in order to give you a small example, like for example, you have seen an AND gate, okay, like A, B and C. Okay, now when it comes to the output, what on which values this output will be depending upon? The input values, right? Any change in A or B will be changing C. Is it or not? If there is no change in A and B, then there won't be change in C. If there is change in A and B, there will be change in C. Similarly, just like any change in the output will be affected by the inputs in combination circuits, similarly, in always also the sensitivity list work. Okay, so again in this sensitivity list, again you are having two types of sensitivities, like level sensitive and edge sensitive. Okay, level means nothing but positive level or negative level. Okay, either you will be going for positive level or negative level. Mostly you will be seeing this level sensitivity in combinational circuits. Okay, positive level or negative level means nothing but either 1 or 0. Okay, when it comes to either 1 or 0, you will be going for combinational circuits. Is it or not? So that is why level sensitivity is for positive level and negative level for combinational circuits. And then the second one is edge sensitive. Edge sensitive means posage or negage. Okay, for this nothing but posage and negage. Where you will be seeing this posage and negage? while you're designing flip-flops, is it or not? Nothing but sequential circuits. Okay, so basically for level sensitives we will be using for combinational circuits, and for edge sensitives we will be using for sequential circuits. You can just remember it like that. Okay, now how are we? This is the syntax for always. Like, see, always when there is single statement, then you can execute it in this way. Now if you are giving a sensitivity list, you should be mentioning the sensitivity list with at the rate symbol before. Okay, always at the rate sensitivity list, and then if there is single statement, there is no need of begin and end. Okay, now for example, if there are multiple statements, you need some begin and end. Okay, always at the rate sensitivity list, begin and end. So the always block repeats continuously throughout the simulation. This we already discussed. This sensitivity list brings a certain sense of timing. That means it's nothing but in order to, like, it will be giving some conditions, like it will be putting some limitations to the always block. We can call it like that. Sensitivity list, what it will do, it will be putting some limitation to your always block. That means depending upon the variables that you are mentioning within the sensitivity list only, the always block will be working. That means it is having some limitation there, is it or not? For example, if there is no sensitivity list, then what happens? There will be no limitation for always block, and it will be executing forever. Okay, that is why mostly you will be using sensitivity list in the always block. So whenever any signal in the sensitivity list changes, the always block is triggered. Always block is triggered means nothing but it will be executed. That's it. Okay, so this is a small example for the always block with sensitivity list. See, I am writing an example for AND gate. Okay, module AND gate. So for AND gate, I am taking three inputs I1, I2, I3, and one output OUT. Okay, now for example, what I am writing here, always at the rate. Okay, now I am mentioning this is my sensitivity list. If you see, I1 or I2 or I3. Okay, this is my sensitivity list. So what I am doing, I1 or I2 or I3. So any change in this, that means this is my AND gate, I1, I2, I3. Okay, this is my out. So for any change in these values, I want to talk it like this, like for any change in this input, the output value will be changing. So by putting this theory, like this language into code, how is it? I1 or I2 or I3 begin. Okay, you no need to write begin if there is only one statement, but for just if I'm writing with begin and end means I can add some more statements here also. Okay, that is why mostly we'll be using begin and end. Out equal to, okay, I1 and I2 and I3. This is my logic. Okay, this is my logic for this AND gate. So I'm writing within this logic. Now if you see, when this logic will be executed, when always block is triggered, and when this always block will be triggered, when there is any change in I1, I2, I3. So when there is any change in I1, I2, I3, this always block will be triggered, and when this always block triggered, then the statements within the always block will be executed, and then end. This is how you basically write. Okay, you can either mention it like this. Okay, like if there are only three set of values, and if you want to change for every value, then you can mention it like that. For example, if there are some 10 set of values, okay, and you want to your always block to respond for all these values. Okay, that means for every value that you are mentioning, you are going to write it. Now what happens? Now instead of mentioning all the values here within the always block, you can just mention it with a star keyword, like always at the rate star. Okay, and then your block, like out equal to I1 and I2 and I3. Clear? This is how you basically do. Like always at the rate star. Okay, star, either you can mention it like star or some variables. Okay, but what is the thing that you shouldn't do? You shouldn't just leave it like this, always at the rate empty. Okay, this empty parenthesis is dangerous. Why is it? We'll be discussing the next topic in the next slides. So this is how you can write. Either you can mention all the variables, or you can just keep a star. Now what happens if you keep the star? What is the difference between keeping the star and mentioning the variables? For example, if you are having some four variables here, I4 also, but if you want your always block to react only for these three values, then any change in I4 will not activate this always. Okay, it will ignore the value since you have mentioned only three values. So any change in I4 value will not be included in this always block. Okay, that is what. But when you are keeping star means you are including all the variables. Okay, like any change in all these four variables, this always block will be responding. Okay, that is the difference between mentioning the variables and mentioning the star. Star means you can mention that whatever variable that you are declaring inside the module. Okay, that means whatever thing that you are declaring as inputs, for every value it will be changing. Every value the always block will be activating, because I have told that star, that means anything. Like you can just represent it as anything you need. Okay, so this is how the sensitivity list will be working in the always block. Now, okay, so here is the question for you. If there are no timing control statements within an always block, then what happens? Okay, so what is the meaning of this? If there are no timing control statements within the, for example, okay, let me explain with you it with your example. So here I want to generate a clock. Okay, now by using this always keyword, I am using to generate a clock. So in this, see, module TB reg clock, initial clock 0. That means since I am using the initial block, so this clock 0 is only executed once. That means at the first value the clock is 0. Fine. And then comes always. Okay, now always hash 5 clock equal to negation of clock. Now what happens at the first 0 time, as initial block will be executed at 0 simulation time. Okay, we have already discussed it in the initial block. Initial block will always be executing at the 0 simulation time. Now what happens? 0 time delay. So that means at 0 time delay the value of my clock is 0. Okay, at 0 delay time value of my clock is 0. Fine. Okay, now after 5 time units, that means always hash 5. Now what happens? After 5 time units of delay, my clock will be nothing but negation of clock. That means what is the value before value? That is opposite of that. That means yet 0 simulation time it is 0. Now after 5 time units, what will be the value? 5. After 5 time units the value will be opposite of 0, nothing but 1. Okay, then again this always loop, only I have mentioned that hash 5, I didn't mention any sensitivity list and all. I just mentioned that hash 5 clock equal to negation of clock. Now what happens? For every 5 units of time delay, your clock will be generated like first positive, negative, and so on. So 5, 10, 15, 20, 25, 30, 35, in this way your clock will be generated. This is how the clock will be generated. Okay, and then until if I didn't give this particular value like hash $50 finish, then what happens? This clock will be generating it continuously. If you didn't mention this particular dollar finish, then what happens? The simulator will be continuously running and it will enter into the zero infinite loop. Okay, so in order to avoid that, I have given that hash 5, but after 50, that means after 40, 45 and 50, after 50 there won't be any more clock generation because I have stopped the execution. So hash $50 finish. Okay, about this dollar finish also I have explained it in the initial block, so just check it out there only, right? And then end module. So this is how I am generating the clock. Okay, now for example, okay, here comes the question like for the previous slide, what if there are no timing control signals? Here comes the question for you. Like for example, if I didn't give this particular hash 5, now what happens? Always, okay, clock equal to negation of clock, this is my particular one. Then what happens? So basically, yes, it is starting at 0 similar time delay, it is 0, fine. So at 0 time delay it is 0. Now here always clock equal to negation of. Now at 0 simulation time only clock will be negation of clock. Okay, that at that particular 1 and then 0 and then 1 0 1 0. In this way the clock won't be generated, only this will be flipping to 0, just like a switch on or off. In the similar way there won't be generation of the clock, it will just be in that particular 0 till at 0 time delay only the clock will be changing from 1 to 0, 0 to 1, again 1 to 0, 0 to 1. In that way the clock will be generating within the 0 time delay only. Okay, so this is how basically the thing is, right? So that is why here if you see the note I have mentioned it clearly. It is mandated to put a delay in always block while generating the clock, otherwise simulation hangs due to zero delay infinite loop. So because as I already told you, if there is no time delay, then at that particular 0 time only it will be 1 0 1 0. So in this way there won't be any generation of clock. Okay, so that is the reason why you will be going for the delays in the always block, right? So this is about the delay in always block and about the always block, like sensitivity, what is the sensitivity list and what is the delays in always block. So in today's class I'm going to ask you one question. So you have listened about what is always block and what is the sensitivity list and all, right? So in today, what is the question for you today is, so from today's class I thought of asking a question daily for you. What if, okay, question for today is, what if there is no sensitivity list in always block? Okay, so what if there is no sensitivity list? This is the question for you. If you know it, just comment it in the comment box to me. Okay, and if you don't know it, wait for the next class where I'll be explaining the answer for this particular question. Okay, if you like my explanation, please do like, share and subscribe my channel. Please share this video to all those who are also a VLSA aspirants. Okay, thank you for today. We'll be meeting in the next topic.